Elon Musk's recent sit-down interview with the Economist's editor-in-chief, Zanny Minton Beddoes, at Tesla's Texas Gigafactory has generated significant discussion across business and technology circles. Unlike brief social media commentary, this interview offered a structured outline, focusing on a strategic 10-year planning horizon, extending to 2036. The conversation unfolded against a notable corporate backdrop, following quarterly performance updates and recent public filings across his ventures. However, the core discussion moved past short-term financial metrics toward a far broader issue: the structural transformation of the global economic model, driven by artificial intelligence and physical automation. Musk addressed his recent high-profile engagement in government policy initiatives, signaling a pivot back to his core focus as an engineer and system architect. In this detailed analysis, we will examine the primary takeaways from the interview, from the theoretical obsolescence of traditional currency to physical infrastructure bottlenecks and international competitive dynamics. At the heart of Musk's forecast is the year 2036. By his estimates, digital artificial intelligence will exceed the combined cognitive capacity of all humanity within 5 years. However, the fundamental shift occurs on a 10-year timeline as algorithms move from pure software to physical embodiments via humanoid robotics. Musk introduces the concept of a quasi-infinite economy. The underlying logic rests on a basic definition. An economy is the total output of goods and services provided. If the production of goods and services is transferred to autonomous physical systems, supply is no longer constrained by human labor output. This underpins the most widely discussed assertion from the interview, that money will gradually lose its traditional role by 2036. Musk argues that when essential needs, housing, transport, food, and healthcare can be produced at scales far exceeding human consumption, traditional currency loses its function as a tool of allocating scarce resources.
Distinguishing between digital and physical automation is central to this analysis. Today, progress is heavily concentrated in software and large language models. However, Musk noted, software remains constrained inside data centers. An AI model can write code or generate text, but it cannot construct physical infrastructure or assemble hardware without physical actuators and effectors. This explains why Tesla's strategic focus has increasingly shifted toward Project Optimus in humanoid robotics. Scaling physical robotics presents complex engineering challenges: designing specialized actuators, implementing vision-based autonomous navigation, and optimizing power efficiency. According to Musk, transitioning from purely informational AI to mass-produced physical robotics represents the single largest industrial shift in modern history, eclipsing previous industrial revolutions. Addressing labor market disruptions, The Economist raised the critical question of workforce displacement as automation accelerates. In response, Musk presented a counter-argument to traditional inflationary concerns, positing that deflation will become the dominant economic trend. When human labor costs are removed from manufacturing, the marginal cost of goods trends toward raw materials and energy inputs. Rather than a standard universal basic income, Musk describes a future of universal high income. If total product output increases exponentially, wealth distribution mechanisms change. Goods and services become abundant enough that purchasing power constraints weaken. Under this framework, labor becomes an elective activity or personal hobby, analogous to growing food in a home garden for leisure rather than economic necessity. The discussion also covered structural risks. Musk placed the probability of a catastrophic AI scenario, the P-doom metric, at roughly 10 to 20%. Nevertheless, he considers attempting to halt technological development both impractical and ineffective. Instead, the primary alignment strategy relies on grounding core models in truthfulness and a fundamental orientation toward human well-being. In terms of immediate technical constraints, the primary bottleneck today is not raw silicon availability, but power grid capacity and data center cooling infrastructure. Demand on electrical infrastructure is outpacing current energy generation expansion. On the geopolitical front, Musk highlighted the rapid pace of technological integration in China, noting that Chinese manufacturers are steadily closing the gap in domestic chip hardware production and will remain major competitors to Western AI ecosystems. This interview provides clear insight into how tech leaders are constructing their long-term strategic roadmaps for the next decade. While the proposed timeline of 2036 for an economy of complete abundance faces real-world hurdles, ranging from regulatory friction and policy resistance to supply chain constraints, the core vectors identified remain central drivers of current development: physical robotics, changing labor dynamics in the race for energy generation capacity. Whether these exact timelines hold true or shift, the structural evolution of core economic institutions is already underway.